So here we have our question with the image of set C being defined as y and y, function of x being equal to y for all x in C. We want to use this definition to prove that the function of A union B is equal to the function of A union function B. So our no is going to be what we're given, basically the question. So if x1 equals x2 and x, then f of x1 is equal to f of x2. We're going to use this later, so that's very important. And this is expanded in the definition of image of C. This is our expanded no here. What we want to show is basically our question here. Which also means that we have to show that not only is the function of A union B a subset of the function of A union function of B, but we also have to show the reverse. So if the function of A union function of B is a subset function of A union B. So now we can start our proof. So first, we want to prove that the function of A union B is a subset of the function of A union the function of B. So what we're going to do is we're going to take any y that's in the function of A union B. And this means that there exists some x in A union B that satisfies the equation we were given, which is f of x equals y. This is from our no. So after this, we're going to be able to see that since x is in A union B, x is either in A or x is in B by the definition of a union. So, from our no, we can also see that y is either in f of A or y is in f of B. Because since we have x in A or x in B, we see from our no that f of x equals y, that we also have y in f of A or y in f of B. So since we have this y is in f of A or f of B. And so from that we can see that f of A union B is in fact a subset f of A union f of B. So that's case one. That proves the first half that we needed to see. So we've done that one. So part two. So next, we will look at f of A union f of b being a subset f of A union B. So once again, we can take any y that's in f of A union f of B, and we'll have, there exists, we'll have some x in A or some x in B, based off of our note, because since we have a y in f of A, that means there's an x in A, or we have a y in B, f of B, so we have an x in B. And this shows us that A is a subset of A union B, because we get it from this, which we are taking from what we have to show. We have to prove this, so we're going to assume our hypothesis and then prove it. So A is a subset of A union B, and we also see that B is a subset of A union B. From this, we have f of A union f of B being a subset of f of A union B. Since we have our hypothesis and we have shown that each of these sets are subsets of A union B, it's the same, based off of our note, it's the same for the function, because the function of x is equal to y. So since we have our y's showing that each set is a subset, it shows us that the function is as well. And since we've proven that both f of A union f of B is a subset of f of A union B, and we proved that f of A union B is a subset of f of A union f of B, we can now see that f of A union B is equal to f of A union f of B with our given conditions. And there we have our proof.